Hello, good morning. Hope you are doing well. Today we are conducting a general presentation for the curriculum 01 for the schools Ibn Rushd, and actually I'm trying to uh, give you a full, just a second. Mm, um, okay, great. So I'll be sharing with you right now. As you can see, hello, Mrs. Kelvin. How are you doing well? Can you hear me? Mr. Kelvin, good morning. So I'll start my presentation since I'm obliged to terminate in 1 hour because I have another webinar following this one. So today it's not a technical webinar, it's a general information about the curriculum 01 and how the integration should be in order to reach STEAM education using 01. So first of all, I'd like to clarify a major point that to integrate STEAM, it's really critical, and we have to understand the educational approach for implementing STEAM at school. But before this, I'd like to give an educational definition of STEAM simplified in case you were asked about محمد صباح النور يعطيك العافية. Can you hear me well? Muhammad, please give me a sign if you can hear me well. Okay, so I believe it's okay. Uh, uh, so what I was saying that the educational definition for STEAM is very important to have it in mind because the moment you will be asked about this implementation, you should know all the background and the setup you should do. So implementing STEAM at school, it's simply offering during the academic year many skills at many levels for students in order to be able to reproduce or to create a product, an object, a solution by using materials that we can find at home, in a classroom, around us, in a supermarket, wherever we go. And those objects or the material can be a bottle of water, can be a rubber, a scotch tape, a box, an empty box, a piece of wood. So any kind of objects that you have around you will be used in order to create let's say this object in STEAM. And the purpose of creating this object or this solution is very clear, is to initiate students to be creative, innovative, to share data, to collaborate with their friends, and to think about problems that we are facing in our real world, to reshape the solution or even to create something which is really new and was not done before. So by that, we are creating, let's say, really we are creating really students who will be critical thinkers and innovators later on. So from this purpose,
Morning, Mr. Wassam. Can you send the link for the computer training right now?
so I was saying that for this purpose, for this purpose, uh, uh, we have to think in this implementation in a really wise way. Because implementing STEAM requires a specific background for students. I mean, we cannot ask students to start creating STEAM projects without offering them a general information, a background regarding many topics and many skills, especially in technology. And when we talk about STEAM, it's not like a push button. I mean, I cannot press a push button and say for students, go ahead. We have to start by creating STEAM projects. We have to prepare them. And preparing students for STEAM projects requires a solid infrastructure in terms of curriculum, in terms of materials, in terms of trainings, follow-up, support, research, vision, and planification. So it's basically a must for the for the school to figure out at the beginning of the year a roadmap clear for what we are aiming to by the end of the year in terms of productivity for STEAM projects for each single level. And by that, I believe that on our digital platform, we have added a template document to guide you somehow how to start with implementing a STEAM at school. And I repeat to say that today's webinar is not a technical webinar. It's a general information introduction to our vision for this solution and how we see things from our experience in order to reach a successful implementation. And each time we start working with a school, believe me that this is a challenge for us to make it a success story, and we will put all our efforts and experience in order to reach this point. I will share with you in a while a document, a Google form document in order to fill it, to make sure that we have your WhatsApp number and your email number in order and to have an assessment regarding your previous experience in terms of the skills that you should have to make sure that where we will be focusing our future technical webinars. So But by implementing the vision of implementing STEAM, as I said before, it should follow two paths. The first one is the implementation of a solid uh, curriculum that we are going to discuss today, which is the ZERO1. And in parallel, we will be implementing a second path, which is the STEAM path. But for sure that the vision for the two paths should be aligned in order to reach the goal that we are aiming for. And when I gave at the beginning the definition of STEAM to make students reach this capacity of building or creating or innovating a product or a solution for a problem that we are facing right now, this means that we have, as I said, to implement this curriculum and to offer students through the curriculum, just 1 second, please. Okay, so through this curriculum, all the skills that students might need in order to create it. And when we talk STEAM, I'd like to go back a little bit to the definition. STEAM projects, it's very important also to identify this issue that STEAM implementation could be without technology and could be with technology. And when we say STEAM without technology, I mean collecting from around us whatever we can find in terms of box, bottle of water, scotch tape, ribbon, papers, anything that we can find. And then we just try to create the product that we are aiming for. This is what we call STEAM without technology. But when we go for STEAM with technology, so here it's quite different because we should implement technology that requires skills in coding, in algorithm thinking, in robotics, in microcontrollers, in 3D design, in conception, maybe in database, and so on. And the difference between STEAM without technology and STEAM with technology is very clear and very simple. And you should also keep in mind this difference. STEAM without technology will lead to objects and to solutions that cannot interact with the environment. I mean, if I create a solution or an object without technology, it will be a manual object and it cannot interact automatically regarding the behavior of the, let's say, the environment. If it's cold, if it's hot, if it's night, if it's day, it's sunny, it's raining. So it's isolated from the environment. But when we go through STEAM with technology, so here things are different because we believe that uh, 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 we have to implement the technology, and here the product created will interact with the environment more or less when there is changes, when the full of sensors in order to have this interaction. So basically, our goal for sure is to go for projects and STEAM with technology, because ZERO1 curriculum offer all the background for students. Now, how the implementation should be done, also for us, it's really clear. It's really clear because we have to figure out the two paths that we have planned for. So you have the first path, which is the curriculum. So you as ICT teachers you are invited to implement and to respect, like for 80 or 85% or even 90 if you can, the content of this curriculum, because we are talking about a curriculum that has like 25 years of experience and implementation and enhancement. So be sure that our curriculum ZERO1 will be the right solution for this implementation. And it is planned to be given 1 hour per week for students. You have all the resources needed. I mean, the moment you log into our digital platform that I'll be sending right now on the chat. So ZERO1.education is our digital platform. I ask you to create an account as teacher in order to get all the resources you need in terms of lesson plan, teacher guide, answer keys, tutorials, the softwares, extra database for assessments. So everything you might need, you will have it. It's really clear. It's really, let's say, the vision is to help you implementing the curriculum, and you will be having the textbook, the paper book, the printed book, in order to be able to use it in a classroom where students will follow a clear step-by-step. And here, believe me that all the teachers that are using our ZERO1 curriculum, they have the same comment or the same impression that students will lead alone. So you as teacher, you will have the role of a maestro, just to guide the students and to try to push them to execute the exercises and the projects as is alone, and to follow step by step those instructions. So as I said, for the implementation of the curriculum, you will have all the background needed for this implementation. Yet still you will be needing the implementation of the curriculum that you can see in front of you, which is the detailed scope and sequence that that is presented inside the books. And our scope and sequence is clear enough to give this confidence to the teacher, to show him the roadmap for this curriculum. So as you can see, we have like 4 topics: topic 1, topic 2, topic 3, topic 4, and topic 5. And mainly, I don't know why my mouse is not working properly. So mainly, the first 2 topics, which are computer knowledge and data science, and office application, are common for all the proposed curriculums on the market. So there is nothing new here, especially for the Office application, Word, Excel, PowerPoint, which we believe that it is a must for students, at least in primary school, to have this knowledge about how to create a document in Word and Excel, how to prepare a presentation, and so on. And for the first subject, which is computer knowledge and data science, here we can say that uh, uh, it's not about explaining for students like what is a mouse and how to what is a keyboard. And so we believe that those skills are really simple for them because they are in their implemented in their daily life. But the main uh, objective of this section is to show students this relation between data and the hardware. And when we show them this relation between data and hardware, we are explaining them indirectly all the concept of the input and output devices, including the content of the or the different items of the let's say the computer, and this relation between the commands to share and to manage files like the open, save as, new, and so on. So this is to say about section 1 and 2. Section 3 is really important for us since we are talking about STEAM. We cannot imagine STEAM without art, without creativity. And when we talk about art and creativity and drawing and cartoon drawing and 3D drawing, there is a big part of this that could be done manually on a sheet of paper and digitally on a computer. That's why what I think there is a question. Mrs. Hajar is asking, we start by which section? Actually, we give this freedom choice the for the teacher in order to select which section to start with. I mean, I don't know previously which curriculum. Okay, and there is another question, which is how many section per trimester? Uh, Look, to simplify things, uh, our book is made about like 80 to 88 pages, and we are talking about like 35 lessons, plus minus. So each chapter for each grade level is formed about sometimes 9 lessons, sometimes 6, sometimes maybe 3, but it's rare. So I cannot give an answer to your question in general. You have to go through each topic alone or each grade alone in order to see the table of content and the number of lessons per grade, per number of lessons per chapter. And based on this, you can select which chapters to combine or to give uh, per trimester. So here you are talking about a trimester, not semester. I think that it's divided into 2 trimesters or 3 for Ibn Rushd, because I knew that the Ministry of Education gave this freedom of choice between selecting 3 or 2. So there is another question. Do we need to use our education email to register as a teacher in this website. As you wish. You can use your personal email, you can use your professional email for the school, depends from what you have, because some of the schools don't have professional email, so it's open. You can use your Gmail, Outlook, Hotmail, any or the professional. So I was talking about the how to select the chapters to fit with a semester or trimester. So if you can give me an answer regarding how many, I think Dr. Laura is with us, so maybe she might give us she might give us an answer about the participation. Just 1 second. Meanwhile, I'd like to send you a link where please can you fill during my presentation if it's possible to to visit the link I gave right now. It's a Google form in order to know you better in terms of background. And for each teacher, the grades he is teaching and what are the skills or the background that he has in terms of knowledge in our ICT curriculum. So later on, of course, we can help more for that. So so I was saying that regarding the, just 1 second. I was saying that it's regarding the section 3, it's very important, and I repeat it again and again, that the moment, Marwan, maybe we have to start with the what is a computer hardware and software according every level. Mrs. Marwa, you have the total freedom to choose where you can start with which level. I believe that as a teacher, I'm talking because I'm a teacher like you. So as a teacher, I know and I believe that the teacher is the maestro in its classroom, and he has all the, of course, with the coordination of the administration and the academic directors, but he has the right and she has the right to choose any topic to start with. And sometimes I do give my recommendation, like for example, if you feel like you have to keep students attract and attached to this, or to create them this motivation, why not to start for lower grades in grade, let's say 4, 5, 6 with Scratch, okay, which is a coding language which create this interactivity and this challenge for them. And then you go through other chapters. And always I recommend that, and it was planned, it is planned in our curriculum that Mrs. Amy is saying that warm-up videos about robotics and microbot for sure, and we can help in this. Just I'm taking note. And as you can see that most of the times, we kept the chapters that are creating some challenge for the teachers, like Arduino, PHP, MySQL for higher grades, robotics, sometimes coding. I believe that this is very important to keep a time frame for teachers to experience and to practice a hardware implementation before going over with students in the classroom. This is why this implementation is flexible, and whenever you want and whenever you need, I will be giving you my WhatsApp number. I'll be 96133806333. So whenever you feel like you want to ask a question, or you are like facing some issues and some problems, do not hesitate to send me a WhatsApp, and I'll be replying. And my email is support@01.education. Again, I'll be sending the link for the Google form in order to fill in the data regarding your previous experience. For those who joined later this webinar, because at the beginning we were few teachers. So this session is recorded, and by the end of the session, I'll be sending the recording in order to review the missed part from it. So as I said, when we talk about STEAM, we have to prepare students in order to start implementing topics and skills. And basically, the section 3 gives you this opportunity, because we believe that in 3D design, sorry, what's happening here? So in 3D design, okay, we have implemented two sections, which are cartoon drawing and Tinkercad, because as I said before, that when we talk about art, it's a must to reach creating product design, creativity, and object for solutions that we are facing in our real world. And art is divided into two main chapters or sections, which are the cartoon drawing, where students are invited, as you can see clearly in our curriculum, from KG till grade 6, to enhance the skills of creating or drawing any object they need, starting from the geometrical basic shapes, like the square, rectangle, circle, lines, dots, curves, and so on. And the moment they reach this level, and it's very easy to assess students since they are producing projects. And the way we are showing those lessons is clear enough for students to figure out the different steps that they should do in order to reach. And by the end of each lesson, okay, students will be asked to open their digital software like Paint or any other software, and then to go to redraw on the computer the cartoon drawing done on a sheet of paper using a pencil. And the Tinkercad topic, which is really a very important topic or skills to offer for students, because from a level of 2D design, okay, they are moving to 3D design. And when we move to 3D design, here things are really challenging, and we start creating real objects that we can easily transform them like from the digital to print them on a 3D printer in case you have in your computer lab a 3D printer, to show students that this this path of implementing cartoon drawing in 2D and then moving to 3D will lead to create solutions that we will be using in robotics, in microcontrollers, in order to reshape our vision of creating STEAM projects. So it's very important for this path. I remind you, for those who were late for this session, that today it's not a technical webinar. It's a let's say it's an introductory webinar to introduce you as teachers for the spirit and the vision of our curriculum and how the implementation should be. And later on, we will be coordinating with you, with the academic directors at your school, in order to define another webinars, typically and exclusively for each topic that are challenging for you. And the Google form I've sent will define, will give us a clear idea about the urgent needs for you teachers. So if by getting this document, we will analyze it and we will propose for the administration and for the academic directors a roadmap for the trainings the soonest. We can start early next week in order to make all the topics clear for you in terms of not really technically how to implement, but educational wise, how to introduce each topic alone for students in order to convince them that this implementation will help them in their future and will help to create this implementation of STEAM. So this is regarding the section 3, which is cartoon drawing, the 3D design and animation. Section 4, which is the biggest section actually, and this section covers algorithm, Scratch Junior, Scratch Small Basic, Python for coding, and then it will cover robotics MBO2 for robotics, covering the microbit, Kitronic, and Arduino for microcontrollers, database, Access, PHP, and MySQL. So you can figure out clearly that this section is the biggest section where you can identify for each grade level the green circles where those topics are given. And I'll be back for this. And for the section 5, you can see that the implementation of artificial intelligence and machine learning will be implemented on the platform for coding and for robotics, especially for grade 4 till grade 9 for this year. And later on, we will be developing it for higher grades. It's a matter of time. So when we go back to section 4, we can see that developing skills in algorithm and coding in different languages, starting from grade KG till grade 12, this will help a lot students to get familiar with the other skills like for robotics and for the microbit and for even Arduino. Here we are talking about the coding blocks. So I'll be launching now. Uh, Please, if you can confirm on the chat, if you can see the program M block, which is like Scratch. Can you see it? Please, can somebody confirm me? Okay, great. So when you start preparing your students, for the coding with Scratch Junior and with Scratch, the mission will be 80% done for robotics and microcontrollers in terms of microbit or Arduino, simply because we are working with a same interface, which is the coding block. Knowing that for robotics or even for microcontrollers, always it's possible to switch between, as you can see here, we can switch between blocks and coding in Python. But for beginners, it's better to start with blocks. So you can see that the interface is almost the same. So you have here blocks, you have a sprite, but with a slight difference, which is here you can see that I have devices, sprites, and background. In Scratch, you have only sprites and background. For devices, we are talking about the robot. And the categories here, for sure, you have new categories like the audio, the LED, the display, the motion sensing, LAN, AI, and IoT. Okay, all those categories are related to the robot MBO2, but you can see that event, control, operation, variables, and my blocks are related to Scratch, the normal Scratch that you know. So I believe that once you start preparing students for Scratch coding, and I believe you did this job in the previous year, so it's very easy to continue with robotics. Later on, we will fix a special webinar for robotics. I'm taking note with different layers to show you the different layers on the teaching process for robotics, because as teachers, we are not asking to be technical. It's not that anyone can go over YouTube, over any platform, and they can watch like some videos regarding let's say robotics or any topic that we are dealing with. But the issue here, it's really different, because we believe that in any topic, we have to slice the educational process and to divide clearly for students the different layers for each topic. So I can give you just in less than 1 minute the different layers that we will be offering in robotics. So in terms of the teaching process. So the layer one will be the general knowledge and the introduction, as one of our colleagues just now said, that warm-up videos regarding to explain them how to understand more the robotics process and the robotic world. Layer two will be the hardware. We go through single details about the hardware. Layer three will be the software. Layer four will be the STEAM implementation, how to implement robotics in STEAM projects. And layer five, how to prepare students to participate to national and international robotics competition. And to know that the robot that we are working with, which is the MBO2, is linked to an international competition, a national and international competition called the Make X. So always, we have to think about, I'm sending again the Google form in case you did not fill it, just to fill it. Till now, I have only 8 who filled the Google form. So please, I'm asking you to, you are 24 here, so there is lots of teachers uh, who did not fill this form, and knowing that with the coordination of the administration, we will be giving you a certificate of participation for this general introduction. So it's very important for you in terms of professional development to have this certification. So please go on this Google form and fill in the data to know you better in terms of your need for the future trainings. So I was saying that when we go over this program, it will be simple for the students. If we go through the other platform, which is Tinkercad, which is tinkercad.com. So also you see that it's also okay, I have to log in. Okay, so it's also saying, so when I go through create a circuit program, and by selecting the Arduino to start coding the program, look here, you have the blocks output, you have the blocks input, notation, control, math, variables. So the logic will be the same, even for the microbit. Okay, so it's very simple, and it's very important for you to know that this implementation will help you a lot to establish the STEAM and the curriculum implementation at your school. So of course here we will be giving you later on a detailed presentation for the robotics, for the microbit and Kitronic product, and for the Arduino. And the hardware that you will be using during this process will be the robot MBO2 with its option to be customized by using extra 3D design printing. And on our website, you will find later ready-made objects to be printed on a 3D to be used on this robot. Of course, having a 3D printer will help a lot in this process of productivity. You will be using the microbit as a microcontroller for lower grades. We are proposing a set of hardware for STEAM implementation, like the greenhouse, the lab bit, the air quality station, the street light, the access gate, and the traffic light system. And for higher grades, we are proposing a set of Arduino with different sensors like the gas, temperature and humidity, rain, servo motor, soil moisture, ultrasonic sensor, and others. And back to the paths that we are figuring out in terms of implementation, we see that this implementation as we said before, will be for the curriculum on a frequency of 1 period per week. So here, students will learn in a progressive way the topics proposed in the curriculum, but in parallel, the implementation of STEAM should be planned since day one. And by that, uh, I will try to open a document that I have created on the platform. Just 1 second, please. Hopefully I can find it easily. Okay, great. So this document, it is on your platform. Please also, I will try to type the ZERO1.education. Please, for those who attended late this webinar, please go on ZERO1.education and create an account for as teacher in order to give you access for all the resources that we are proposing as lesson plan, teacher guide, answer key, the softwares, the videos, extra exercises for assessments, written assessments. And what you can see here is a plan, a roadmap for this implementation. And you can see that this roadmap will help you a lot in this clear vision. I have a question. Yes, it's normal, Yazan, that you need to have an activation from our IT department, and you will have it in less than 24 hours. It's normal, okay? So just to check the Google form. So till now we have only 10 teachers from 25 present. So please, there is still 15 teachers who did not fill the Google form in terms of assessment and to figure out the needs. So back to the document I was explaining. So you can see here that all right. You can see here that incorporating STEAM into a school curriculum provide so there is an introduction. The implementation process will be structured around the following key element for each grade. So for each level grade, you have to define with, of course, the coordination of the administration, the number of projects per grade, the subject or the ideas of the projects, you have to define them. You have to precise the involved discipline for each project. So list all the disciplines that you might need in order to do this implementation. As you know that when we talk about STEAM, we talk about disciplines concerned in math, in science, in languages, in art, and of course in ICT. So you have to think about this implementation and to see the discipline, the hardware and software requirement for each project. It's very clear to identify, and believe me, we can help a lot to give you ideas and to answer any questions you might need to select the students for projects and the estimated number of periods that you might need. And after that, when it's clear for you as this implementation. So you go through to fill the template for the STEAM project. So the grade level, the project title, like here, which is awareness for STG recycling, the disciplines involved, ICT, science, English, and math. Hardware, no need for hardware since it's a Scratch project, software requirements, Scratch. You have to define the name of the students involved in this project and the number of hours estimated. And then you go through the description of the project in terms of objectives, in terms of project overview, introduction to recycling and SDGs, brainstorming and storyboarding, learning Scratch basic, project development, testing and sharing, reflection and discussion, and the outcome of this project. So this document is available on the platform. You can download. I don't think it's as a PDF, but we can upload it as a Word in order to be able to modify. I will take note of that. Upload Word document. Okay. So I believe that it's clear enough. It's clear enough that the implementation of yes, we are progressing. So we have till now 11 from 25. Still 14 participants did not fill the Google form. There is an improvement. Thank you. All right, thank you. So I was saying that it's clear enough that it's impossible to implement or to reach this productivity of STEAM projects by let's say by working on within a curriculum process, because you saw that for each project you need a remarkable amount of hours and time in order to finalize it. And for that you have to think about those two tracks that we've planned before for the Google form. I will okay. I posted again. I posted again on the chat. So this Google form will allows you to fill some data regarding the requirements you have or you need, just to have a clearer idea to be communicated with the administration of the school later on. So basically, it's really clear that the two tracks, as I said, or the two paths that I introduced at the beginning, which are the curriculum track and the STEAM track, are clearly different. But in terms of preparation and in terms of vision, they should be aligned together. I mean, you cannot ask for students to create STEAM project related to robotics or to Arduino or to 3D design without offering them those skills in the curriculum. And be assured that the moment you offer those skills for the students in the curriculum track, you will reach, no doubt, minimum 80 to 90% of students that will acquire those skills. And from there, with the differentiation of projects that we are proposing for each lesson, almost each lesson. قطعت الكهرباء. Sorry, sorry, please just confirm me if you can hear me because I have a problem of electricity. Can somebody give me a sign if you can hear me?
Yes, we can.
All right, thank you. So, okay, great. So I was saying that, uh, uh, I was saying that it was clear enough for you after this general introduction that the two paths that are visually not the same. I mean, the curriculum path, which is independent from the STEAM path in terms of implementation, but in terms of coordination and alignment, they should be aligned together. I was saying that we cannot ask students to do a STEAM project without without offering them in the curriculum skills in, let's say, 3D or Arduino or robotics or database, whatever they need. So this is why this implementation of the curriculum is very important to follow. And the moment you need, just 1 second, please. The moment let's just the moment you propose for students all those skills, you will be reaching the point to realize or to produce STEAM projects. And as I said, most of the lessons that we are proposing as in terms of activity at the end of each lesson, that you will be finding this in the lesson plan that we are currently updating for this year. You will find this differentiation process for this implementation. I believe that I gave you a clear idea about the curriculum. I'll be posting in the chat for the last time. As you can see, till now we have only 12 participants who filled from the 24. Still we have like 10 who did not fill, or maybe yes, 10. So hopefully we can reach a total number of the participants to fill in this Google form, to have a clearer idea about your need in order to communicate it with the administration to plan for the next technical sessions regarding the different topics that we are planning for. If you have any specific question, please